All right, folks, so here is a question that was sent in by a student. This is from the combinatorics permutations and permutations and combinations assignment. I believe this is lesson one of the questions from the workbook. This wasn't assigned, but it is in the lesson 1 workbook. I believe it's lesson 1. So in this example here, the question is how many ways there are of getting from A to C in each of those diagrams, passing through each point at most once. Okay, what does that mean? It means that if we're starting over here, if we go down this way like that, so now we're passing through point B, we cannot go back. For example, we cannot go this way because that means we would be going to point A a second time, right? So once we're in point B, we can only proceed either down this way or this way or this way. Okay, that's what that statement means. So this is a problem that we can solve using the fundamental counting principle. So we're going to be using the FCP here. And what we need to recognize here is that we have several sort of pathways. If we're at, for example, point A, we have 1, 2, 3, 4, 5 choices. We have 5 different paths we can take in at point A. Once we are at point B, now we have 3 different paths to choose from. Okay, so for diagram 1, we would simply put in 2 placeholders for our fundamental counting principle. And the first placeholder would be the number of paths we have from A to B. The second placeholder is going to be the number of paths we have from point B to point C. So from point A to point B, we had 5 paths to choose from. From point B to point C, we had 3 paths to choose from. 5 times 3 is 15. So we have 15 different ways of getting from point A to point C in diagram 1. Right? In diagram 2, it gets a little bit more complicated. So we have the paths. So from A, we have the paths up here. Okay. Once you take one of these 3 paths up here, you're going to end up at point B. B1, actually, it's called B1. And then you have 3 more options. If you would take one of the paths down here, you're going to end up at point B2, and you have 2 other paths. So these 2 paths here are not the same paths that lead from B1. So there are sort of 2 separate scenarios here. You go either sort of in the paths that are up here, right? So you would go down this way, one of these 3, and then you have one of these 3 to choose from, or you would pick one of the lower paths, in which case you're going to go one of these 3, and then you have these 2 to choose from. Okay, so what we need to do here is we need to determine, we're going to use the fundamental counting principle, but we need to determine the number of ways we can get from A to C passing through B1. And then we have to determine the number of ways we can get from A to C passing through B2. And then we have to add it up. Okay, because those are two sets of independent paths. So we're going to have for the yellow paths, the ones on top here, we're going to have two placeholders. The first one is the number of paths from A to B1. The second one is the number of paths from B1 to C. Then we're going to add to that the number of ways there are to get between A and C passing through B2. So this placeholder here is going to be the number of paths we have between A and B2. And this one here is going to be the number of paths we have from B2 to C. Right? From A to B1 we have 3 paths. From B1 to C we have 3 paths as well. From A to B2 we have 3 paths. And from B2 to C we have 2 paths. Okay? So 3 times 3 is 9. 3 times 2 is 6. 9 plus 6 is 15. Okay? And then finally, in diagram C, the approach is exactly the same. So the difference here is that we have 3 sets of paths, right? We have sort of the these upper paths here, all right? Then we have another pair of paths down here, the green ones, right? And then finally we have the lower paths, these ones here. So we're going to do this the same way as we did it in diagram 2, except now we're going to be adding 3 things together, okay? So let's sort of flesh it out here. So first we have a placeholder for the number path from A to B1 times the second placeholder, which is the number of paths from B1 to C. So these are the paths in yellow. To that we have to add the number of ways there is to go from A to C through B2. So this one here, this placeholder here, is going to be the number of paths we have from A to B2. This one's going to be the number of paths we have from B2 to C. And then finally we have to add the number of ways there is to get from A to C through B3. Okay? So this placeholder here is going to be the number of paths we have from A to B3. And the last one is going to be the number of paths we have from B3 to C. Okay? This should have been B1 actually. Okay, from A to B1 we have 1 path. From B1 to C we have 3. From A to B2 we have 2. From B2 to C we have 1. From A to B3 we have 3. And from B3 to C we have 2. So 1 times 3 is 3, plus 2 times 1 is 2, plus 3 times 2 is 6. Okay, so this is going to be 5 plus 6 is 11 different ways of getting from A to C. Right? I hope that helps. Until next time.